Okay, so corrections on the previous video. I thought about it some more. And so I was confused between two things, which is negative infinity equals positive infinity. But positive infinity also equals zero. So how does it, and obviously negative and positive infinity are not equal. So how does that work? And actually I was confusing the two types of infinity. So we're dealing with something called p-adic, uh, like p-adic numbers or p-adic numerals. I don't know. And those are really cool because they let you solve a bunch of problems with infinities by just representing it as 2's complement. So, and we actually have two kinds of infinity, or so in 2's complement, right? You say you have a 32-bit integer. You have the unsigned integer limit and the signed integer limit. So like 2 billion 147 something versus 4 billion. Um, and those matter here. So 0 is actually the unsigned infinity. So 0 equals like let's say again for the example, is there gonna be 4-bit integers, so our infinity will equal 16, and then our infinity is gonna be 8, and our negative infinity is gonna be 8, and those are actually equal. Yeah, so the infinity, wait, did I just say the infinities weren't equal? No, they are equal. They are equal, but they are not equal to 0. Okay. So if we have tallies, so we're gonna have 0, 1, 2, 3, 4, 5, 6, 7, 8. And this is our infinity. So basically you can imagine this as going off like infinitely far. Because like as our actual like limit, our integer limit tends to infinity, this line will tend to go higher and higher. So you can just imagine this like going, you can imagine we're drawing more and more of this fractal until we go infinitely. And so that means that 0 is this. Or no, sorry, 0, so yeah. So to get 16, so this is symmetric, right? So this is 8, we could keep going, and it would be like this. So 9, 10, 11. Oops, this is higher. Okay, let me redo that. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this one just goes. This is our actual, no, this is 0. So you can imagine this. You can imagine like drawing, this is our line of symmetry. You could wrap this entire paper around, and this would be the infinity slash negative infinity. And then here you have your negative numbers. And here is 0. You can see 0 goes all the way up. And because this is all symmetric, so you can imagine rolling this paper again, and then you would start again here. Here you're wrapping around. So this is actually 0. This is 0. This is, this is 0. And if you look at it in an unsigned way, it kind of looks like the infinity, except it's actually 0. And if we go back here, that would be the same because it's all symmetric. So 0 just goes infinitely far. And infinity here goes infinitely far this way. And then negatives, for the negatives, the infinity 0 goes up, and then negative infinity goes that way. And I'm trying to think about why the directions are different. It's just this way goes towards. There is no there's actually no direction here because there's no negative versus positive. They're equal. So I suppose in the direction of lower values, you go left. The lower values are left, obviously. So if this is 1 and you go to the left, then you're gonna get 0. But if you're already in negative, if this is negative 7, then when you go up, you're going towards a lower value, which happens to be negative infinity, which is the same as positive infinity. So yeah, pretty cool.